Welcome back, everybody. In today's lecture, we're going to try to tackle the very big, sometimes daunting area of psychology called behaviorism. Now, it's important to note that we're not necessarily deviating too far from cognitive and psychology. In fact, some of the cognitive psychology stuff that we've started to talk about are really critical components to this new area that we'll be just spending two classes on, behaviorism. But what we're going to see as we start off in this discussion is that there is a slight difference between what a cognitive psychologist looks at and what a behaviorist looks at. And we're going to define what behaviorism is all about, but as you can tell by this title, the main focus is going to be on one aspect of behaviorism called classical conditioning. So we'll break down the terms and the concepts of that later, but let's first just understand how we got to where we are. So if you look back to our previous classes, you'll notice that a lot of our discussions revolved around how we're able to get some type of reaction to the world around us. We spent a lot of time talking about our nervous system, talking about the process of sensation, and then we started looking recently at this topic of perception, how we're able to take those signals coming into the brain, make sense of them. Now, obviously, the next step in this process, if we're looking at the human experience, is once we've made sense of these things, we decide to react to them, or we at least react to them, whether or not there's decision behind it. This reaction process is something that lots of people in the early 1900s started to turn their attention to when trying to understand different components of the mind. And it eventually led to the formation of a new area of psychology that I alluded to earlier called behaviorism. And we're going to define exactly what behaviorism is as we progress, but I always want to provide people with sort of a forewarning before we do that. And that's the fact that when we start getting into this, for some reason people tend to get a little uncomfortable with some of the philosophies and aims of behaviorists. I want you to understand right off the bat that it is okay to have disagreements about the scope of what behaviorism is all about. But that doesn't mean that you just get to take a mulligan on this or not learn any of this information simply because you don't agree with the philosophies or some of the things that people in this area did. This is a very critical area of psychology to understand if we need to kind of have a better understanding of what psychology was like as a whole and how psychology got to where it is today. So let's start by first defining what behaviorism is. Behaviorism essentially is an approach by psychologists to try to understand principles of the mind by studying the observable, looking at the observable causes of a behavior and the observable outward manifestations of a behaviors. Essentially, their goal is to try to find a way to quantify how the mind is manifesting itself in the outward world. Now, it's based on the assumption that a lot of the things that we're doing can be whittled down to just the observable. It's also important to note, though, that just because many behaviorists focus their attentions on, as the name kind of implies, overt behaviors, it doesn't mean that they assume that all the internal stuff going on is immaterial. Many behaviorists argue that emotions and thoughts and all the other things that we say are the sources behind our behaviors are probably indeed critical catalysts to why we do what we do. But they also say that sometimes it's tough for us to really differentiate between the true causes of our behavior when we start to get into that internal mind. Partially because the mind works very fast, and partially because maybe we're not quite as in tune to our mind as we think. A great example of this would be, say, if you were walking down the street and somebody came by and bumped you, or maybe even just got a little too close to you. So you decided to yell and say something at that person. Now, if somebody asked you why you did this, you might give explanations like, well, they scared me, or they got me upset, or, I'm just not somebody that likes that type of thing happening. And these things might be logical explanations for what happened. But behaviorists would say you're relying a lot on your internal states of minds to make that assumption. Why don't we just look at the surface? Why don't we look at how, if there's a scenario where your attention is turned in one particular place and somebody gets within a certain proximity of you and that causes your physiological reaction of a jump or a startle to occur, your next behavior is probably going to be to say something. It's not necessarily obviously the most, what's the word I'm looking for, beautiful, I guess we could say, explanation for why we did things. And there probably are some things that we miss in that formula. But the key point is that we don't have to rely on internal states of minds to talk about what was the source of a behavior and what could potentially be the trigger of that behavior again in future situations if we try to explain that situation in that manner. I'm not saying that those thoughts and emotions weren't a part of it. It's just sometimes very difficult to dwell in that area if we truly want to be scientific about what causes things to happen. You might, when hearing that, be a little bit more comfortable with behaviorism. It's also probably important to note that just like there's people that disagree with some of the general behavioral principles out there, there are behaviorists that disagree with the limitations of the behavioral models. There are collections of people in our history of psychology that we tended to call radical behaviorists. There's actually a term coined by somebody we'll be discussing a little bit later in this class named B.F. Skinner. Actually, it's our next class that we'll be talking about him. And this term kind of highlights individuals that had an adamant belief that our behaviors really were just a manifestation of the outward world, and that our interpretations of things through emotions and thoughts was actually missing the point. In fact, we could, if having absolute control over everything in a person's environment, predict down to the T exactly what somebody was going to do and who they were going to become. One of the biggest advocates for this was the very controversial individual in our history named John B. Watson, who in lots of talking circuits and lots of attempts to try to explain the behavioral movement made very outlandish comments like the one you see pictured here, where he said, "Give me a dozen healthy infants, well formed in my own specified world to bring them up in, and I'll guarantee to take any one at random and train him to become any type of specialist I might select. Doctor, lawyer, artist, merchant chief, and yes, even beggar man and thief, regardless of his talents, pensions, tendencies, abilities, vocations, and race of his ancestors." That's a mouthful. That's a pretty bold statement. Obviously, there's a lot of problems and innuendos within this that we might be set back by, but it also implies something very interesting. It was something that was assumed by many behaviorists, that many of us talk about genetics and predispositions and thoughts and emotions being the source of why we do these different things. But Watson, like many behaviorists at the time, argued that most behaviors are really just a byproduct of the environment that we expose people to. If we do X, Y, and Z to somebody, they're going to turn out in some particular way. If other things happen, well, then they'll move down a different path. This idea of Watson's was really controversial at the time. It suggested that really it wasn't us internally that were the motivating factors behind our behaviors, but instead it was just the world that we were being exposed to in the way it was exposed to us. So Watson was pushed and challenged to give some evidence for this idea. So he did a number of studies over the years to try to kind of give a concrete example of how this worked. But the one that he's most famously known for is his research on a number of children looking at the concept of phobias. And one particular children he highlighted in a lot of his work named little baby Albert. This child that he was able to get access to in an infant care unit and run through a series of different tests to show that he could cause a child that displayed no predispositions for fear or other problems to develop one very quickly through the right environment. In particular, what he did with little baby Albert, after finding that baby Albert had no preconditioned fears or phobias of specific things, was he brought baby Albert into a lab and with one of his research assistants named Rosalie Rayner, who there's a whole nother story behind that idea that you can look up on your own if you'd like. But anyways, with Rosalie Rayner, he brought baby Albert into this lab and started exposing Albert to all these different things. He'd let him play with toys, let him watch different things moving, and then eventually he'd bring in this little white rat. This white rat would be brought into the room and be allowed to wander around just for a little bit. And while Albert was watching the rat, like everything else that was being introduced to him, Watson snuck up behind little baby Albert's head, and I believe it was with two pots. It might have been two other instruments, but it's not really that important. With two objects, he banged them together really loud behind baby Albert's head, and this caused the very predictable fear reaction and crying and screaming that you would see with approximately 1.5 to 2-year-old. Little baby Albert quickly then was consoled by Rayner and Watson, and they got rid of the rat and they calmed him down. But the experiment had essentially begun at this point. The next day, they brought Albert in, let him play with toys, let him interact. Then eventually the rat came out. Watson snuck behind Albert's head, banged those two instruments together, and immediately again, little baby Albert was crying inconsolably for quite some time. This progressed for several days, each day Albert showing more and more fear to the situation, and in particular, more and more fear to that little white rat. And what really amazed Watson and led him to really push little baby Albert as kind of the hallmark of his idea was that Albert's fears started to go beyond just the little white rat. He also was fearful of fur coats, little white bunnies, anything essentially that was white and fluffy, especially white and fluffy things that could move, were very terrifying to the child. Now, eventually, according to lore / some fact, apparently little baby Albert's mother found out about this situation, and little baby Albert was no longer allowed to participate in any future studies. Now, there are some questions that whether or not there's other factors that were at play. Little baby Albert was in an infant care unit at not so good time in life, so there might have been other elements to this at play. But nonetheless, for years, Watson used this child and other children that he put through these scenarios as hallmark examples of the scope that radical behaviorism could have. And he really embraced that this was the cause of almost all of our behaviors, including our fears. And he insisted that if he had just a little bit more time with little baby Albert, he could not only have produced those fears within him, but he could have easily dispelled them within a few exposures to this rat in the right conditions. This led to people really trying to tease apart what it was behaviorists were defining. 1920s, 1930s, when Watson really started to push this behavioral movement, the conclusion was that what behaviorism really was built on was looking at this topic of learning, how we come to develop behaviors through certain types of associations. If we whittle this down even more, lots of behaviorists went on to contend that learning can really be just found in two primary forms, what we nowadays call classical conditioning and operant conditioning. Both types of conditioning are learning, it's just two different forms of learning that exist. In classical conditioning, we often talk about it being what's called involuntary learning, where we're learning not necessarily to do certain things in certain situations, but to simply automatically respond to certain things as if they were equivalent to other things in certain situations. Well, let's say we're going to be classically conditioned about the stimulus of food. Well, in this particular situation, what we would be doing is pairing a stimulus, like a whistle or a bell or something, to the likely presentation of food. We'll break down this a little bit more as we progress, but just understand that this was one of the ways that we believe Watson was able to instill this fear in little baby Albert, who just Albert learning to associate the white rat with the loud bang that was inevitably going to follow. It's also important to note that classical conditioning doesn't explain all types of learning. There's large numbers of things that we do that aren't involuntary, that seem to be more a byproduct of what we've decided to do when we find ourselves in different situations. That type of learning is what we call operant conditioning. Sometimes you'll also hear people call it consequence learning. And this is what we call a voluntary type of learning, where we're learning to do certain things to produce outcomes like, say, food, as you see in the picture depicted here. Both types of learning can involve similar stimuli. It's just the formulas themselves, when they apply, does vary. And what we're going to try to do in the next two lectures is really break down these types of learning and some of the elements linked to them so we can get a better appreciation of how this behaviorism movement picked up and how a lot of the concepts that are looked at back then can still be applied to our everyday situations today. And to explore this idea, we're going to go back to where behaviorism, many people argue, started. Back to the work of a very interesting researcher in our past named Ivan Pavlov. And if we look at his spanning career, looked at a large number of different topics, most of them related primarily to biology. He spent some time also studying physiology, but if you look at most of his projects and his work, his lifelong achievements, the vast majority of them involved some type of peering into biological mechanisms and the things that were related to them. For example, he did his graduate work on the circulatory system, trying to understand how blood flow actually worked the way it did, and how blood was able to get up places when gravity seemed to be pushing it down in opposite directions. Eventually, his research, if we're talking about his role in psychology, led him to study something that most of us probably don't think of that often, but are using on a regular basis, called the digestive system. He was particularly interested in how our digestive system was triggered, how it started in the initial phase when we were able to produce massive amounts of saliva the first second food entered our mouth. So he decided to set up a lab where he hooked up test tubes to the salivary glands of dogs and presented them with food. Not just the same amount of food to look at how much they salivated, but instead varying amounts of food. His keen interest was to figure out if dogs could gauge how much they needed to salivate to get the digestive process started based on how much food was presented to them. He had this notion that if you gave a dog just a few bits of food, they would only drool a tiny amount, just enough to break down that food and send it down their digestive tract. But if you gave them a ton of food, something that would be overwhelming to them, they would start producing massive amounts of saliva, and in doing so, help them be able to digest that food better. In the early stages of Pavlov's work on this topic, he didn't report many problems. But eventually, he started to run into this issue that he eventually called psychic secretions. This odd phenomena where the dogs in these labs would start salivating before they saw the food placed in front of them. More often than not, they'd start salivating when the researcher was present that was giving them food, or some would salivate when the food dish came out, or even in some cases, just when there was a right time of day when certain people were around. In those cases, the dogs would start drooling. Their vials would be practically full of this drool, this saliva, before the dogs had a chance to even see how much was there. And this created a huge impasse for Pavlov. You couldn't talk about a formula relating to how much we drool based on what we see in front of us if we're already drooling before we know what's in front of us. So he tried tweaking his study a number of times, tried to alter the formula and alter the way the dogs got presented the food, but what he kept running into were these psychic secretions, where the dogs would catch on to what was happening, recognizing what cues were going to indicate that food was coming, and they just start salivating to those cues. So he decided to really scrap this project on salivation and instead turn his attention to these psychic secretions. And in doing so, he took really the first steps in psychology, and in particular in the behavioral movement that started to grow after his research started to become popular. And at the basis of this effect that he found is what we now think of as the framework for classical conditioning. In Pavlov's work, he talked about how the learning process that he was looking at was all reflexory in nature. He said essentially all of us start with this collection of responses to stimuli that we have no control over. These were what he called unconditional reflexes. When someone blows in your eyes, you blink. Someone steps on your toe or they stand next to something too hot, you pull back. These are not things that you have much control over. When it comes to the dogs and the food, his argument was if somebody crams food in your mouth or a dog's mouth, the natural automatic response of your body is going to be to salivate. And this is something that we do seem to have evidence for. I challenge you the next time you eat a meal to try not to salivate. Right? Just put that food in your mouth and don't drool. It's physically impossible to do this. Your body is pre-programmed to do this. There's no conditions that are required for this behavior, this reaction to be initiated when that stimulus is present, hence the reason why we call it an unconditional reflex. If we want to break this reflex down a little bit more, just like Pavlov did, we call the stimulus that produces the response, the unconditioned stimulus, and the response to that stimulus, the unconditioned response. I think I said that right. This reflex, this unconditional reflex, is always the start of classical conditioning. And eventually, when we look at this type of learning, what we add to kind of create this formula is something that starts off as a neutral stimulus, a stimulus that does not produce any reaction on its own to begin with. And in most classical conditioning examples, this neutral stimulus starts to get presented just a little bit before the unconditional stimulus. So in the case of Pavlov's work, usually it was something like a bowl that was presented right before the dogs were about to have food crammed in their mouths. In later iterations of his work, it'd be something like a bell or a metronome or some type of reliable cue that would always signal food was about to be introduced. Food was about to be crammed into the mouth. And through repeated pairings, this neutral stimulus started to create a new type of reflex, something he called a conditional or a conditioned reflex, where now the neutral stimulus of, say, a bell or a metronome or a bowl, whatever it is, converted from something that hadn't produced any response to begin with to now something that was producing the exact same response as the unconditional stimulus. The bell would start produce drooling, just like food being crammed into the mouth produced drooling. And it created this conditional response, in this case of drooling, but it was slightly different from the unconditional response because now it was just to the conditioned stimulus. This was the basis, the framework for classical conditioning that was introduced by Pavlov, and it led to decades of research on all the nuances around it that led to this happening and the impacts that this could have on not only animal behavior, but human behavior as well. Just so you can see visually how this works, I wanted to include this slide that covered the basic formula that we encountered in Pavlov's work, where you have this unconditional stimulus of food being crammed in the mouth, followed by the unconditional response. Then you play, say, some random thing that's not introduced before the food to begin with, like a tone, and that tone on its own produces no response. But during training, you have this repeated pairing of the neutral stimulus right before the unconditioned stimulus. At this point, the unconditioned stimulus still is producing the unconditioned response. It's just now, these animals or humans or whatever we're looking at get exposed to the neutral stimulus just a little bit before the unconditioned stimulus. And eventually, what starts to tease out are now two types of reflexes. The unconditioned reflex is still there. Even if you don't play a tone, if you cram food into a mouth of a dog after it's learned the tone is going to indicate the food's coming, that cramming of the food in the mouth is still going to produce salivation. But the tone also, through repeated exposures, can produce now a new response. That conditioned response, it's just this case, the conditioned response, salivation, is to the conditioned stimulus. We think, well, most people are convinced that this type of learning is everywhere. There's lots of examples of us having these automatic reactions to scenarios, sometimes even undesirable automatic reactions to scenarios, that we can tie back to classical conditioning. One of my favorite examples of this is people's fear, anxiety, and stress reactions, much like the one we saw with little baby Albert, where something produces a natural fear response, like a big loud bang behind our head, or an argument, or something that causes bodily harm or the potential for bodily harm. And then those things that produce these automatic responses start to get paired with some environmental cue, something that starts off as just a neutral stimulus. My guess is that you can think of a number of responses you have to environments that are completely benign, that shouldn't create that huge fear reaction, that you can trace back to classical conditioning. Maybe, say, you get really nervous the first second you walk into a classroom, or maybe going into a specific area from some childhood experience makes you very nervous or uncomfortable. Or maybe, say, you hear a certain voice or smell a certain cologne or perfume or something, and this automatic trigger of stress is induced. And I'm guessing if you think about this a little bit, you might be able to source this back to something that was naturally producing fear, naturally producing these strong stress reactions. That's where classical conditioning really finds its hold in our kind of everyday life explanations. And this is the type of stuff that we started to identify once Pavlov introduced this concept that led to so many people trying to understand the nuances to it, expand it in attempts to understand the specific situations that related to our lives. Again, I think I need to reiterate, classical conditioning cannot explain why we do everything. There's lots of voluntary behaviors that we commit that cannot be whittled down to classical conditioning. But there are probably a number of things within us where we're reacting without thinking that could potentially be linked to this type of learning. And if you'd like to, please pause. Think about some situations in your life. Try to break it down within this formula so you can understand it a little bit better and appreciate how encompassing this idea actually is. So, where else did we go after the work of Pavlov? You might have noticed I've mentioned a few times now that the work of Pavlov's led to not only him exploring lots of new concepts and adding wrinkles to his formula, but others spending decades really trying to expand on the basic principles of classical conditioning. And one of the first places we went to, Pavlov in particular, was to explore how this process was actually acquired and how it was then forgotten. And this led to him introducing these ideas of these things that he called learning curves and forgetting curves. His argument was that classical conditioning was not some magical light switch that just clicked on at some point and clicked off if something was broken. It was instead this gradual transition from a situation where you have a stimulus, a neutral stimulus that produces no response to begin with, but over sequential pairings, it starts to produce closer and closer responses that mimic the unconditioned responses that are really the kind of first step to classical conditioning. For example, with the dogs in his experiments. He didn't say that a dog wouldn't drool to a bell in the beginning and then magically after 3 or 4 trials with the bell being played before the food was presented, the dog would start drooling everywhere, that 3rd or 4th ring, when the food was presented. Instead, he'd say that after a couple trials where the bell rang and then the food came out, the next trial, the dog would start to drool a little bit to the sound of the bell. Not nearly as much as the actual food being presented, but they'd salivate a little bit. After 4 or 5 more trials, they'd salivate a lot more. And eventually, he'd say learning had officially happened when the drooling to the bell was just as profound as the drooling to the food itself. And if you continue pairing those two elements together, the bell with the food, learning is maintained and that bell stays a conditioned stimulus. But if that learning is broken, if you get to a point where the bell is no longer reliably indicating that food's going to follow, then you start to trigger what he called a forgetting curve. These moments where what was a very strong classically conditioned conditional stimulus starts to lose its potency. So if, say, the bell stops indicating food's going to come, After a few times where you ring the bell and no food arrives, eventually the dogs would salivate a little bit less. If you keep going more and more, the salivation becomes less and less prominent. And eventually, if you've played the bell a whole bunch of times and never presented food, forgetting will officially happen where the dog won't salivate at all to the bell and will revert back to what we would call a neutral stimulus. And this basic formula was something that Pavlov and lots of others explored, not only just in this instance, but across a wide range of species with reactions to stimuli and different reflexes of interest to show whether or not we could see variations in learning across species and variations in situations and stimuli that were worth noting. This has been linked to things like intelligence, linked to the ability to have kind of precognitions towards specific types of stimuli. And it's led to a whole discussion about the complexity of learning and how it's not just this basic formula, even if it does make some intuitive sense in its base form. Another thing that Pavlov and others eventually explored was what happens after forgettings occurred. Are we really done when we no longer respond to, say, the bell after we had originally learned that it was tied to food? And Pavlov explored this in a number of different ways. One of the ways he looked at this was what happens after, say, that conditioned stimulus goes away for a while. If it does, are there any after effects when that conditioned stimulus returns? A great example of this would be if, say, a lab did have a research assistant giving a dog food over and over again, and the dog started drooling all over the place every time it saw the research assistant, and then that research assistant was tasked with a new thing. Maybe they were asked to clean up after the dogs or take the dog for a walk. So eventually the dog stopped drooling to this research assistant. Let's say then, after the dog had sort of forgotten that the research assistant used to be paired with food, the research assistant went on spring break or left for a number of weeks for a vacation. When the research assistant returned, would there be any lingering effects? Well, Pavlov found that there were. He called this spontaneous recovery. He showed in numerous studies that even though something looked forgotten, if there's a long pause where the now reverted back to neutral stimulus isn't present, a neutral stimulus can produce sort of a weakened conditioned response when presented again. Moreover, if, say, that stimulus does start to get paired with the unconditioned stimulus again, learning curves get much, much steeper, which means learning happens much faster. We call this heightened sensitivity. So in essence, that research assistant, if they ever start feeding that dog food again, in the example I just gave, the dog will learn very quickly to start drooling to that research assistant again. Now, in addition to these iterations that looked at these things called learning curves and forgetting curves, another thing that was explored was what happens if we tinker with the pairing process. In most traditional examples of classical conditioning, the neutral stimulus, which is again bound to become a conditioned stimulus, is presented almost immediately before the unconditioned stimulus is presented. Well, what happens if maybe that nice, easy sequential order isn't there? Well, people have given names to these other types of pairings that could potentially produce different effects. One type of conditioning is what's called trace conditioning, where a neutral stimulus is presented, then there's this long pause. And afterward, after the neutral stimulus has been gone for an extremely, well, not always extremely, I guess just some period of time, the unconditioned stimulus is presented. What researchers want to know is if that pause kind of eliminates the possibility of that neutral stimulus becoming a conditioned stimulus. And what most research has found is that it doesn't necessarily help the learning process, but this pause can, over time, be overcome. It's just the learning curve is usually a lot more flat. It takes a lot more exposures for that neutral stimulus to start to produce some type of conditioned response. Something sort of similar to trace conditioning is something called delayed conditioning, where you present a neutral stimulus, in this case long before the unconditioned stimulus. But in delayed conditioning, that neutral stimulus lingers. My favorite example to kind of differentiate these between these two and the first original version of classical conditioning would be, say, if I wanted to turn a light on, and that light would then cause your seats to have an electrical jolt pass through your body. This works a lot better when you're sitting in a giant classroom, but envision a light turning on in a classroom, and boom, right after the light turns on, you get shocked. It wouldn't take very long for you to be jumping up to that light turning on. That's what classical conditioning is. If I was doing trace conditioning, I'd have that light turn on, then turn off, and say a couple seconds or minutes, however long I wanted the delay to happen, nothing would occur, and then after that time had passed, boom, you get hit. Eventually, you'd start to associate that light with getting shocked, especially if that gap started to get closed. But it would take you a lot longer to learn that that light was reliably indicating you were going to get shocked. This is what happens in trace conditioning. With delayed conditioning, that light would turn on, and it would be on not just for a few seconds, but maybe a few minutes. There would be a long delay between that light being presented and still being presented before the unconditioned stimulus arrives. It's not that there's no reliable connection, it's just that the time frame is a lot longer in delayed conditioning. And just like with trace conditioning, what we tend to find is that learning can take place. It just takes a lot longer. If we're looking at that moment when things actually start to decay, break away, the longer you get, you can see the decay happening with the delayed and the trace conditioning. But oddly enough, as we get closer and closer to that unconditioned stimulus and conditioned stimulus being paired, you can also produce a weird effect that deletes or removes classical conditioning as well. One example of this kind of moment when classical conditioning doesn't work perfectly is when we talk about something called simultaneous conditioning, where the neutral stimulus isn't actually presented before the unconditioned stimulus, but at the exact same time. When that occurs, conditioning can sort of occur, but it's not nearly as reliable, and oddly enough, the learning curve tends to be much more similar to trace and delayed conditioning. And in fact, if you go past that threshold and now move to a situation where the unconditioned stimulus actually precedes the neutral stimulus. So for the example of the dogs and food, maybe the dogs get the food and then the bowl is presented. Or the shocking example I gave, maybe you're shocked and then I turn a light on. What we see is that this pairing, this formula, this kind of moment by moment activity actually produces almost the reverse effect, where we don't see an animal or a person pairing that neutral stimulus with the unconditioned stimulus, which means we never produce that conditioned stimulus response pairing. All of these little subtle tweaks, changes, were again the things people started to explore once we really understood the power of classical conditioning. Another area that was very closely related to that wasn't whether or not we mess with the time frame as much as whether or not we mess with the stimuli. What we see is that all stimuli are not equal. There are differences across species for sensitivities to certain types of stimuli. Pigeons and vision, rats and taste, dogs and smell. These are things that have been proven in lab after lab to be very highly sensitive learning areas, where these animals can be classically conditioned within just a few pairings if the reflexes revolve around those sort of specialties of these animals. We also see that novelty helps a lot for all species. So if there's a new smell for a dog, it's better than an old smell. If there's, say, a new word for humans, it's a little bit more effective to pair that word with some type of stimulus than an old word. And this is something that has lots of impacts on the learning curves, forgetting curves that we spoke about earlier. Another thing which has been interesting is what happens once learning's occurred. Can we tweak the stimuli and still produce the same responses? This has gotten us into this area of what we call generalization and discrimination. And it's produced a whole new set of curves that talk about the strength of the conditioned response when there is a difference between the newly presented stimulus and what had become the conditioned stimulus. In our examples, let's say, the dog's got a different colored bowl, not the bowl that they'd seen every time before. Would they salivate as much? Or if I turned a different light on in the room, not the one that was reliably predicting you were going to get shocked, would you jump just as much? And when we look at the behavioral curves there and talk about generalization and discrimination, what we're saying when somebody generalizes is that their response is pretty darn similar to what it was when the original conditioned stimulus was presented, even though now we've tweaked that stimulus. If somebody starts discriminating, human or animal, what we start saying is that we're getting closer to the point where this different stimulus, this one that's not technically the same as the conditioned stimulus, just similar, is too far away, too unique from that conditioned stimulus to really produce a conditioned response. There's books upon books looking at all the differences between species and stimuli and learning curves and forgetting curves and generalization and discrimination curves. It's a daunting world to get into once you start doing research on it. But what's really neat from it is that there have been so many applications that we found, as I mentioned before. But it really is important to recognize that these applications don't get into everything. And that's where I want to leave us. I want us to remember what we've done so far is just introduced ourselves to the world of behaviorism. We've learned a lot about a type of learning called classical conditioning, but we're not quite there yet in terms of understanding all of behaviorism, because there's still one other major component that we need to explore to understand this area well and to understand how it gets applied in so many situations. And that's what we'll be looking at in our next class when we talk about operant conditioning and the very famous work of B.F. Skinner and many of his other colleagues. I'm going to sign off for today, but hopefully I'll see many of you soon when we do take that journey into operant conditioning. Take care.